So it is my really pleasure to introduce Dr. Claudio Cunha. Okay, I know him for many years from different events. One major event is Transportation Issues Board annual meeting. We are sharing the same committee, and he is well known in the logistics area. So Dr. Tacuna is a full professor in the Department of Transportation Engineering at the Polytechnic School, University of Sao Paulo, Brazil. He has previously served as department head and deputy head, and currently serves as director of the Center of Innovation in Logistics Systems at University of Sao Paulo. Dr. Cunha is also Fulbright chair at the University of California, Davis. His research focus on freight and purchase transportation modeling, network design, urban logistics, and mathematical modeling applied to logistics transportation systems. With nearly 40 years of experience in transportation planning and logistics, his scholarly work has been widely recognized, accumulating over 2,300 citations in peer-reviewed journals. Also, I would like to let you know that we are cite his work in our research as well.
Thank you. So, thank you very much. Good afternoon to everyone. It's a great pleasure to be here at Florida Atlantic University. It's a great pleasure and honor. So, the idea here is to bring you a brief overview, motivate people about what we call the power of optimization, how optimization can be used to solve real-world problems in transportation logistics. I think I can... Okay, now it's working.
Yeah, but I don't know how we can go. Okay, try it. If you cannot, I am gonna change it from here.
I think I can skip the presentation as Professor Evangelos Kaisar has introduced me already. So I'd like to start about how transportation has evolved in the recent or among years. So some 130 years ago, one of the major concerns, what would we be doing with manure? Okay, the cities of London would all be covered with manure. Nowadays, technologies has profoundly changed and reshaped how transportation and logistics work. We can see a lot of different companies that did not exist 10 or 20 years ago. All of them relies in technology and transportation and logistics. We have several issues related to transportation and logistics. As you can see in both pictures, you have two Coca-Cola trucks delivering to the same market because they require small vehicles. And you can see on the right-hand side pictures, two buses of the same routing, one following each other. So one of them was delayed and the other was moving too fast, so the two buses were following each other, which is inconvenient for service for passengers. We also have a lot of problems related to the design of networks. I know that you here do a lot of network design here as well. And we also have problems related to crews, scheduling crews in general. So basically, operations research can be defined as the decision science that use mathematical models to solve real-world problems. MIT used to brand operations research as an MIT approach to decision-making, okay? And more recently, by the way, it's one of my passions, okay? I'm passionate for applying operations research in general. And not until recently, the Operations Research Society...
Sorry, this picture from NASA?
Yes, correct. And until recently, a society of professionals in operation research would market it as operations research as the science of better, how executives are making bolder decisions in less time, the analytical tools that they use, okay? So why to use OR? In my case, OR is to solve real-world problems that we call combinatorial, problems in which the number of potential or possible alternatives is too high to be enumerated, no matter how good you are on spreadsheets or anything else. Okay, so I would like to introduce to you what is the Oscar or the Academy Award for Operations Research. The Edelman Award that's awarded every year by the Informs Institutes for Operations Research and Management Science has recognized benefits, savings, economies above 431 millions since its inception in the early 70s. So basically, I'm gonna show you some of these applications in transportation and logistics. Basically, I will start with Amazon. Amazon was one of the finalists of this year's award with a network design optimization tool in which they wanted to regionalize, cluster fulfillment centers and etc. to expedite and reduce costs. It allowed them to save something between 10% in delivery distance, gains in delivery speeds, fulfillment from within the region to between 62 and 72%, and etc. Another finalist of this year's award was Lufthansa Group. So how they manage recovery, flight recovery due to incidents like bad weather, like some sort of problems that will disrupt operations. So they have a system that works in their operations control center that will take care of the whole activities that are related to their operations, from flight, crew, passenger, and etc. It's one of the finalists, and they achieve large savings. Another finalist of this year, you see, among the 8 finalists, we are the 3rd finalist of this year's Edelman Award, is waste management. How to solve the different routing problems, residential problems, which means Chinese postman problems, in commercial and industrial problems involving 4,000 routes daily to be scheduled, to be routed in order to manage their operations, okay? And generate these routes in less than 45 minutes. Savings like $11 million every year in labor, fuel maintenance, improved margin improvements, service reliability, and etc. We can jump to this cruise ship ferry system in the Northeast Europe. So they operate 21 vessels, 10 routes. It was the winner of last year's Edelman Awards. Okay, savings of $50 million annually. They applied machine learning forecasting models together with a price revenue optimization system in order to improve their operations. We can jump to Walmart. Walmart was a winner of the 2023 Edelman Award, optimizing their supply chain strategy from designing the network, transforming the network, routing, loading, and doing simulation to see how robust this optimization was. Savings of $75 million, and also savings in terms of CO2 emissions as well. We can go to DHL, finalists of the same year as Walmart. Again, a transportation network optimizer, which involves freight optimization, fleet, round trips, and also point-to-point operations. Okay, so reducing empty miles, reducing greenhouse gas emissions, and maximize utilization of the fleet. Again, they could project savings that would exceed $300 million as well. We also have one of the finalists in 2023, Lift with the reinforced learning algorithm for solving the matching problem, how to assign drivers to requests, to optimize service and to minimize empty miles that are driven by the drivers. Okay. Also a finalist in 2023, a major company, Meituan in China, that delivers food. So basically, they have over 5 million couriers. They operate in more than 3,000 cities in China. Okay, they serve, 7 million customers. So they provided an intelligent system to dispatching those vehicles, those motorcycles to deliver food to the people that are ordering food online. Results, 32 million kilometers in daily travel reduced. Delivery hours increased and delivery time decreased by 20%. We can jump into the World Food Program, how to provide food baskets for people that have been suffering some sort of unexpected event, from a hurricane similar to the one that reached Jamaica a couple of days ago, to earthquakes, to other types of unexpected events. $100 million in savings. We also have 2021 finalist, Alibaba, a major player in the e-commerce deliveries.
Outside of the United States.
Sorry?
Outside of the United States.
Outside of the United States, of course. Sure. Okay, so they have VRP, vehicle routing problem algorithms, for what they call hour level deliveries problem. Okay, how to expedite deliveries for reducing delivery time. We also have in the same routing problem, UPS, some years ago, 2016, was the winner of this pricing for optimizing delivery routes. So they developed a system, dedicated system for them that would allow them to reduce costs, savings to up to $400 million, also emissions, also gas gallons, and etc. So to summarize, and I have not gone through all of them, many of the winners and finalists are companies related to optimization in transportation and logistics. And many of them, some of them that I have not even mentioned, like Flipkart, okay, another e-commerce player, have been working in the field of transportation and logistics. Okay, and I could not, I also have to mention to you that optimization is applied outside transportation and logistics. For the soccer or football, as it's known in some parts of the world, we have the qualifying of South American World Cup in 2018. It was solved by integrated programming. I'm not aware if it has been solved for this qualifying or the consecutive cups, because this was the first time it was developed in order to maximize audience interests, revenues from football. So I'm going to give you now a brief idea of one of the works that I have been able to work. We had a problem in São Paulo that we needed to improve our ambulance system. And we need to understand how improve the ambulance system that was not working, emergency service ambulance system that was not working very well. Basically, at the time, our ambulance system, the city of São Paulo, received around 9,000 calls per day. Okay, works 24 hours per day, 7 days a week, and it has 140 ambulances. vehicles. It serves different areas with very high population density, other areas very more rural, and etc. Basically, from these 9,000 calls, 1,200 ambulances are dispatched because some of the calls they do not require an ambulance to be dispatched. So there is a previous service in trying to understand what is the need to send an ambulance. And this is a public service, okay, covered by the City of São Paulo Authority. So it's a service that's free for anyone. It doesn't cost anything for it to be helped by an ambulance. Basically, demand varies over time and days, and response time was around 30 minutes at the time, or within 27 minutes for 98% of the calls. So the question was how to improve it, how to reduce the response times. Okay. First, an obvious answer would be add more ambulances. So if the work's not working so well, we need to buy more ambulance, have more ambulance. But how many more? Where should they be located? Because ambulances are not like Uber drivers. They are not driving around waiting for a call. They have to stay in some ambulance stations waiting for the calls.
Dispatching.
Yes, you have a dispatching system. So basically, new stations were required. We need to relocate the stations. How many? Where? And as we had a lot of bureaucracy to open new stations. So it's time consuming. We don't have buildings that are adequate for that. It's costly to renovate or change the buildings and etc. So basically, the idea of the person that was responsible for that was to use some movable stations, some stations like this one. This one is located in a kind of park, central park that we have in São Paulo. It's not that central, but it's a kind of central park. So you can build it in public spaces in very short times, and it's not very expensive. Okay? So basically, the idea was to overcome those difficulties in terms of expanding the number of stations or relocated those that have become poorly located. Basically, as I said, they can be installed in any public spaces, easily relocated. So we, at the time, developed an algorithm that was very new at the time. That this type of algorithm, they would mimic the way some sort of insects would work. In our case, it was a bee colony algorithm in which you have some different types of scout bees that perform random search to find food source. So food source are good potential areas of the solution space that would allow good solutions to be found. We also have working bees that will be doing a fine detail exploration of those local areas. Okay, and we have overlooker bees that will try to identify new regions of the solution space. Why did we use bee colony at the time? Because I want to understand how this algorithm would work. Okay, I want to understand if it was a good idea at the time. Nowadays, I probably wouldn't be using this algorithm, except that for the leader of the project, the guy that hired us to develop this project, it was very easy for him to explain the logic of algorithm for the people in general. Those mathematicians have some algorithm that will try to mimic how bees work. So it was easy for him to communicate the idea, and everybody believed on that. Okay? Basically, we analyzed several scenarios. A very uncommon scenario, which is a sort of greenfield scenario, in which we get rid of all stations and we start from scratch. This doesn't happen. You don't change things this way. And also, we considered how we change the locations. We tried with expected response times as of 5, 10, or 15 minutes. also call durations of 2-3 hours. You would ask me, why a call duration of 4 hours, 3 hours? Because the ambulance goes to the site, takes someone, and if they arrive at the hospital and the hospital is not ready to receive that patient, it's their responsibility to take care of the patient until it's handled to the hospital. So we had cases in which an ambulance had to stay overnight with a patient that was not in critical conditions. So the dispatching system also has a rule or an important role to understand and to identify to which hospital to send its patient in order to that patient be treated as soon as possible. Okay, we tried all combinations with base locations, ambulances, vehicle repositioning. We divided the week in 21 periods, 7 days, 3 periods per week because of the population and the movement changes. So basically, in this case, our optimization model could reduce response times from 27 to 10 minutes. We could determine the locations for the stations and ambulances. And it was so successful that one of the major newspapers in Brazil, I would say that it might be as important as Miami Herald or Orlando Sentinel. I don't know, these well-known papers. Okay, New York Times, I don't know, something like that. Okay, so basically, it was one page, be inspired changes in our ambulance system. Okay, and show it included the results in which the response times were reduced for up to 10 minutes. Okay, we have a publication on this topic. It was published in this journal. Okay, and we were winners of the I-Force Prize for OR in Development. Okay, they have every time they have a conference every 3 years, they select one of the winners, and we won the prize this year. We were also working with delivering new cars to dealers. This problem has been studied in the literature, just for you to have an idea. But in Brazil, these trucks are longer than they are in Europe. So the algorithms that they were used in Europe were not adequate. And we could also find very good solutions. We have 2 papers published on this problem. One exact approach that cannot handle very large problems, and also an heuristic approach that can solve larger problems. Okay, this is a brief idea of some of the works that we've been doing using optimization. I'm currently work on an approach for determining what's the charge infrastructures for vehicles that trucks that operate in highways, so long distance transportation, with our colleague Miguel Haller from UC Davis. I'm also work with another problem related to electric vehicles with a student. We were working with a simulation optimization model for demand responsive service for first and last mile in big cities like São Paulo. What would be the density of calls that would require a demand responsive service in which you have more than one passenger traveling together? It's like a shuttle, on-demand shuttle bus that will take you to a subway station or a BRT bus, rapid transit system. Okay, we've been working.
Claudio, we just have a BRT in Miami.
Yes.
Yanis told me yesterday. I missed the news, so it was inauguration recently.
Oh, you have a.
The thing is that I shared a video which Lucian shared with me. I saw Dr. Kaiser. He shared with us a video from this BRT system that currently.
Okay, wonderful. So this gives you some ideas of the type of work we've been working together. We worked with transit network design, how to design the routes, frequencies of bus routes. in São Paulo, Brazil as well. So basically some of the reasons of the work that we've been together. Okay, what do I see as opportunities? Okay, the opportunities that I see is real world problems and more realistic modeling, tailor-made applications. It's just like when you are buying clothes. You can buy clothes from the retail store, but sometimes the sleeve is too long, it's too short, and etc. So companies are more and more requiring tailor-made solutions. That's what we are trying to do, understand real-world problems and work with this. Okay? So I think this kind of concludes my presentation. I think you said like half an hour.
I said 2 hours.
I said, oh, no problem. I have some more slides.
It's prepared for 2 hours.
Okay, I'm ready for 2 hours. Okay. This is something that I can briefly tell you that we were working with a real world problem related to two major newspapers competitors. At that time, printed newspapers were very common, and they have an integrated operation. Okay, so the two major newspapers have a huge operation that deliver to 216 home addresses, and they want to optimize their operation. But I think I'm gonna stop here.
Okay. Dr. Cunha, thank you so much for the presentation. Thank you so
It's
much
my
for the
pleasure.
time and the effort you give to this presentation. I don't know if we have any questions from our online or ground audience.
Ask first the online people.
Yeah, they can hear us. Please type it on the chat, or you can just step in and let us know. Are there any questions from here? If not, I have one question.
Oh, sure.
Because you were talking about those real-time problems you had, let's say the one with ambulances, and you were saying about this big colony algorithm you used. How important was the first solution you gave as an input to the algorithm so it starts solving from this point? And what was this, let's say, solution?
I think, first of all, it was not a real-time dispatching system. Okay, we were trying to analyze how to improve the service. So it was not used to in real-time dispatching the ambulance. The idea was how to improve the system, how to optimize the system. So we were using a planning tool. We collected a lot of data at the time to understand what would be the calls. I did not mention, but we also had a queuing theory system because there is some stochasticity in this problem. So we used data for 5 years, historical data for 5 years to understand when the calls happen, and what time they happen, what was the duration of the calls, and etc., so that we could have very accurate data when we were planning the new system.
So let's say the initial basis was based on a forecasting based on
Yes,
historical
yeah.
data you had.
At that time, we did not have AI tools. I would say that nowadays maybe we would be using some AI tool to do the forecasting, the prediction part. Okay, but at the time we didn't. We did all data analysis for that.
Okay. And for this kind of problems, what are the computational resources? Do they provide them to you, or they ask you to?
You mean computational resource in terms of
Computational power, yeah.
Those models were solved in regular computers that we have, desktop computers. So we did not use a very intensive computing power.
Okay.
Sometimes in our projects, we have in our university a high performance computer, a cluster of a computer very intensive. Sometimes we make use of them to solve these problems.
Okay.
I have a question.
Yes.
Actually, not really a question, but could you please tell to our group here about informs with the in 2 words, and also what are the benefits for students if they are able to present there? You attend recent in Atlanta.
Yes.
Also about the job market there.
Yes. You know, Informs is an association that is related to operations, research, management, science. They have an annual conference and they have a practical conference in which this Edelman Award is presented. One takes place sometime between late October and early November. The other takes place between sometime in March or April, and etc. Informs is a huge conference. It has something between 4,000 and 5,000 attendees. A lot of students that have some sort of analytic skills, any sort of analytic skills, not necessarily optimization ones. We see more and more students with AI tools, okay? And they attend this conference for many reasons. First, there are many companies and universities that are there interviewing students for hiring
On the spot.
on the spot. I saw even foreign universities, universities in China, universities in Singapore, that had in place people interviewing candidates for faculty positions. Also, large companies like Amazon,
IBM.
Delta Airlines, United Airlines, they are also interviewing people in order to find good talents for
But
jobs.
it's the first or second interview there, not the final.
Not the
usually.
final, yes. Anyway, they do a sort of pre-selection in order to identify pool of good candidates. Okay?
And personally, I had the opportunity to attend this conference as a student and a faculty, and I was telling Claudio yesterday that I have interview there without even applying. I was going around and they asked me, IBM, Cisco, IBM, Cisco, United Airlines, and another company, or Accenture. Is this okay? So this is something that you can discuss with your advisor if you are working this area. That will be a very good exposure, to the industry.
Yes, so Amazon, for instance, they have some sessions only dedicated to developers that they are doing Amazon. So each session has four presentations, sometimes five, and all of them are people from Amazon. So despite of the recruitment, official recruitment, you can approach someone and talk to this person if you are doing some sort of research that's related to what they're doing there. So it's a very good opportunity. Informs has around 50 to 60 parallel sessions. So in any time, you have to choose for one or between 60 or 50, 50 or 60. But they have a lot of tracks. They have tracks in transportation and logistics. They have tracks in urban transportation, and etc.
We have some questions here.
Yes,
There's three questions.
okay.
Will you please
Okay.
repeat the question?
So the first question from Dr. Cunha is from Mr. Temu. So he's asking, how do you see AI, data collection?
Transportation technology and other ITS definition. I see AI as a very powerful tool in the prediction phase. So AI will allow our models to use more accurate data, more accurate inputs to optimize. Okay, so I see a very bright future in this. I don't see AI tools taking the role of optimization. So I don't see, because it's very difficult for you to train, something to optimize if you are changing routes. Let's give you an example. Some years ago, I think 3 years ago, Amazon, they decided for a vehicle routing competition. Have you heard of this vehicle routing competition for Amazon? Amazon Last Mile. So they offered 5,000 routes, good quality routes, and they wanted someone or a group that would devise the best algorithm to provide efficient routes based on the patterns of these routes. First prize, $150,000. Second prize, $100,000. Third prize, $50,000. And the group that won this competition is a group of people that are working in travel salesman problem, routing problems, and they apply optimization on that. Okay? So let's jump to the following question.
So the following one, this person Libertad is asking if you have completed any work in the field of traffic management, for example.
I have not had the chance of working with traffic management. I think this is a very relevant problem, very important problem. I have not had the chance of working this. In my city, in São Paulo, I would say that 10 to 20% of the congestion that we have in the inner parts of the city are due to malfunctioning or poor synchronization or optimization of traffic lights. It's a pity because you see, oh, it's for people that are riding cars. So what's the problem? So I hear sometimes from authorities, they say, I don't care because it is related to people that are riding cars and we want to get rid of cars. On the other hand, in most of these roads, you have buses, and buses are the first to suffer. Secondly, everybody's breathing the air. So if you have more cars in congestion, you have more pollution. So it's a health issue. So I think it's a wonderful problem. I'm not familiar with it.
Okay, thank
Okay.
you. And one last question, I think, from Mr. Muhammad Khan. He's asking in the transportation system like integrated corridor management, how can optimization techniques can be applied in real time to balance traffic flow between freeways and arterials.
Wow.
This is
Again, this is not exactly my field of expertise. I think this is a very challenging problem. I think even if you don't have an accident, how you balance, those tall charge and with dynamic change that I like you have here in South Florida is a very difficult problem to be solved. I don't know. But anyway, there is plenty of literature on this topic. You probably find something very interesting to learn more about that.
Any other
I don't know if we have any more questions.
question?
From ground attendees.
Any from the
No, I think that was the last one. Yeah. no other
Okay.
question.
Okay.
So with that said, thank you once again.
It was a great pleasure. Thank you for taking the time to come.
So, as a more gesture of small
Oh.
gesture of appreciation, we have some